let's integrate 1 over 1 plus e to the minus 5x dx, and as usual I'm going to walk you through the process of how we think about it as mathematicians. I'm not just going to give you the solution, but talk you through the process. So in particular I'm going to show you how it's okay to make mistakes and give failed attempts to start off with. So here my first thought when I see always an integral is, if I have some expression which is in the denominator or inside another function, like a square root function for example, it's a good thing to try to set that equals to u. Here we have 1 plus e to the negative 5x in the denominator, but the problem is that if we sort of set that equals to u, we get something complicated in terms of du. So if we sort of try, I'm just going to show you this, 1 plus e to the negative 5x, then du is going to equal to minus 5 times e to the negative 5x dx by the chain rule for differentiation, and we don't really see that up top with the dx. So this is just a mental experiment just to say, okay, in that sort of situation, we need to somehow create it up top, or we need to simplify the expression. Sometimes that involves a simple simplification. In this case, I just sort of see, okay, we have e to the negative 5x. Let's try to write it out as a single fraction. You already have a negative exponent here. Let's try to write it out as a single fraction. What we can do is, if we try to do this, we get 1 over 1 plus 1 over e to the 5x. And now that sort of gives us, let's try to make a common denominator. So common denominator is going to be e to the 5x on here. So e to the 5x over e to the 5x plus 1 over e to the 5x. So it's going to be 1 over e to the 5x plus 1 divided by e to the 5x, and that's of course just going to equal to integral e to the 5x divided by e to the 5x plus 1. So that's the trick. So now we see something up top which we can now use to write everything in terms of du, okay, which you couldn't do in the beginning. So that's a standard trick, okay. Sometimes check out my other videos. I've got other videos where it may be more complicated than this, but simplifying the expression, if you don't see an obvious u-substitution, simplifying the expression and creating the u-substitution is a common tactic. And this is a simpler version of it, but in general it works a lot. So now what we can do is we can now put u is equal to e to the 5x plus 1, just put what's in the denominator, and because e power x is its own derivative, okay, and similarly e to the 5x, if I put u is equal to e to the 5x plus 1, then I know that du is going to equal to 5 times e to the 5x dx. And now I can sort of see the e to the 5x up top, so it's nice to sort of write this out as 1 over 5 du is equal to e to the 5x dx. And now we can sort of write everything in terms of u and du, because now we're going to get integral 1 over 5 comes out, it's constant, so we get 1 over 5 times du divided by u. And now we've got this far, we know that the integral of 1 over u is a logarithm, so that's an important integral to know. And so we can get this is 1 over 5 times the log of the absolute value of c plus a constant, which if you write out u, you don't forget the constant and don't forget to put everything in terms of x. With definite integrals, you can avoid that, but we are doing indefinite integrals here, so we're going to get 1 over 5 times the logarithm of absolute value u is e to the 5x plus 1. Okay, now e to the 5x plus 1 is always a positive number, okay, because e to the x is always positive. It's a very crucial property of e to the x. It should really be in your head. I recommend it strongly. It just really helps to solve problems in general. E to the x is always positive, so it's going to be log of e to the 5x plus 1. And if you want, you can keep the absolute value, but you don't need it. So I'm just showing you that. And there you have the answer. Okay, and we can't really simplify. Log of a sum doesn't simplify nicely. If it's a product, maybe we could do something. So that's the answer. So that's the integral. And I'm doing lots of problem solving on my channel, integration, many different topics in calculus, limits, differentiation. My channel is growing, and I really want to create infinite free accessible math education to support everyone. So if you want to support, please don't forget to like, subscribe, and share with your students, classmates, friends, professors, anyone who you think could benefit from my videos. Share it with them, and that will help grow my channel and really help me support as many people as possible, which is my main goal. So thank you for watching, and I'm super excited to see you in other videos on my channel.